So my name's Dr. Mary Dysko, and I'm from Scotland, from Glasgow, and I work as a researcher and some teaching in the University of Glasgow in engineering and also biology. And what do engineers do? Engineers try and solve all kinds of problems, theoretical and practical, so that they can transfer their skills to the general population and make life easier, more interesting. Unfortunately, they also help the saleability of things as well, but that generates income for the economy and everything and for people. But generally, they solve scientific questions involving how people communicate, how they travel, the ease of use of lots of appliances. We work a lot with computers because computers help us deal with huge amounts of data in a way that your brain couldn't do. And we are generally accountable if something goes badly wrong structurally, so we tend to be very, very good at double checking our work. The engineering that I do is related to providing physical cues to stem cells, which are taken from human adult fat deposits. We have stem cells, which are special cells in the body which can change into various types of cells that have a specific purpose in the body. And we are using electrical stimulation to try and help nerve repair. Using stem cells, we are putting them in hydrogels and stimulating with electricity and probably with ultrasound. Haven't gone into that yet. And we will see if this helps the repair of damaged peripheral nerves, that's nerves in your hands and feet. So the human body, while could be thought of as a semi-electrical system, the nerve impulses are electrical pulses. When the nerves are damaged, there's a different electrical signal than when they're working normally. And so we hope that some of these physical cues we can recreate in the lab, some of the ones that are found in nature. So the focus of my research really is, as I mentioned, for peripheral nerve repair, because many people get damaged hands, damaged feet. And when you have that, when you've, your nerves, there's lots in your spine coming out to all parts of your body. If you damage your hands, it's very hard to work effectively, to drive, to type. And we work with plastic surgeons to find models and ways of repairing nerves better. Well, I started out doing physics and maths, and then I did a master's in astronomy, and I became a little bit tired of my whole focus being 15 billion years ago at the beginning of time, because we were looking at the Big Bang, and I started to feel how relevant it was for a lot of people. So that maybe sounds like a negative thing, but I kind of became involved in biology because my PhD was bioelectronics, and I chose it because suddenly it was though I had sometimes you just grow in life and your interests change, and I like the idea of things I could see and touch instead of things that were distant and far away and having to rely on the highest power technology to even ever get a signal from them. I like the idea that things could be physically there with you and that you could manipulate them and possibly design something great. Well, it improves lives by, of course, making things more easy, automated. Our bridges now don't fall down. Our transport is very fast. You can go to London in 4 hours on the train. Incredible inventions of engineers throughout the ages, like controlling electricity. We didn't invent electricity, it was always there, but we take it from nature and we control it. Like we have now all of the powered things that we rely on, not just light and heat, but all of the things that use electricity. and our understanding of mechanics and the flow of air and fluids across objects have led to aeroplanes, which means now we can go all the way around the world to Australia in a day, 24 hours maybe, and that used to take maybe many months. And so certainly without engineering, our lives would be a lot duller. Well, engineering is about a lot to do with physical interaction and coordination, timing, and fine-tuning. So when engineers design an experiment, they have to make sure that it's robust, just like a circus performer has to make sure that his routine is stable and is not going to go wrong when he's nervous, when he's a big audience, when he's relying on it. There has to be a stable element to what he's doing. There has to be fine-tuning and control, and there has to be an element of artistry. Otherwise, it's not worth looking at, and it's also not really worth doing as an engineer if there's no ingenuity involved, because otherwise it would just be done already. So we have to be creative like circus performers, and we have to be brave, and we also have to be very, very careful.